Hello guys, good day. And now let's discuss our last topic for Lecture 7, the characterizations of AB waste. And our last topic for this lecture is about the geologic and groundwater considerations in AB waste management. From our last topic, na-discuss na to tanan, all of those will help us in planning, handling, and designing, and also constructions of agricultural waste management systems. And also, it will help us to know kung saan na to siya pag-utilize, saan na to pag-utilize itong waste, and also to avoid mga pollution sa environment na dili siya maka-affect sa humans and sa other organism, mga living organism. Ang isa na ana is knowing the geologic and groundwater considerations in AB waste management. So in this picture nga gipakita kung unsa tong mga sources sa water na maadto sa underground through infiltration, percolation, infiltration, and uban pa na mahimong groundwater. Also, it shows unsang mga sources sa water na potential na mahimong contaminants or makakos og mga pollution underground. So we have here the precipitation, mga land application of agricultural waste na mag runoff and maadto sa ilalom, runoff from different sources na ay mga applications of fertilizers, pesticides. We have also here the lagoon and feedlot also na asad mga leaking from holding tank and pipeline. Also, katong mga leaks sa fuel tank na ma-infiltrate ug maadto sa yuta and maadto sa groundwater. We have also septic tank and so on and so forth. So, kato sila, maadto sila sa underground and mahimong groundwater. And it also shows sa figure kung unsa tong mga different levels sa soil or geologic material na maagian sa water before it reaches or mahimo siyang groundwater. And ang groundwater dili lang siya for animals, for plant, or for humans, but all living organisms, no? Especially kita nga mga human, mao na tong source sa fresh water. So imagine if we will give or we will have contaminated water, no? So affected tanan. It is because all of us need water, clean water. So let's have a short overview of geologic material and groundwater. So geologic material, or sometimes called the earth material. So it covers all natural and processed soil and rock materials. And geologically, soils are the end of mechanical and chemical weatherings of rocks. So si soils are classified into two classification. We have the coarse grains, mao na ang mga sand and gravel, and then we have the fine grained soil, mao na si silts and si clays. So on the basis of particle size. So si rock sad is mabuo siya through solidification of molten rock and molten rock materials. So mao na si lava and si lava or si magma. So upon cooling, some rock sad is ma-form because of heat and pressure. So now let's talk about the groundwater. So groundwater, by definition, is the water found underground in the cracks and spaces in soil, sand, and rock. It is stored in and moves slowly through geologic formation of soil, sand, rocks, called the aquifer. So naa siya duha ka zone, the upper zone, which is also called the vadose or unsaturated zone, and the lower zone of saturation or phreatic or saturated zone. So tanang tubig beneath the surface there sa earth is ginatawag na underground water, subsurface water, or groundwater itself. So underground water naa siya duha ka primary zones. So, like akong na-mention kagad earlier. So, ang vadose zone contains both air o water sa mga voids niya. And then ang saturated zone mao nay mga interconnect sa mga voids and filled ni sila og water like aning nasa center sa figure. And vadose zone has three components with differing moisture regimes. So the soil water zone, the intermediate zone, and then the capillary zone. So kaning soil water zone mao ni siya ang mga mag-extend sa ground surface para sa root penetration. And ang mga water under this zone is available siya for transpiration and direct evaporation. So depende sa depth sa vadose zone na ay mga water na mag-move downward under gravity, especially during irrigation or rainfall because of surface tension. So, and above sad sa water table kaning na diri sa figure is na saturated zone nga ginatawag na capillary fringe or zone. So, water under this zone is naga-overlay sa water table kung asa ang fluid pressure sa mga pores. So, naay mga surface tension na diri sa zone na mag-cause sa water na mag-rise. So, mo ni ang nasa picture. And now, let's move on sa definition sa aquifer. So, aquifer is a saturated, permeable geologic unit capable of storing and conveying usable amounts of groundwater to wells or springs. So, aquifer may be confined, unconfined, or perched. And kaning unconfined aquifer is also ginatawag ni siya na water table aquifer. So kaning confined aquifer is an aquifer below the land surface that is saturated with water. Naa siya mga layers diri sa confined that impermeable materials means not allowing the water to flow above or below the aquifer. So mauna ang reason na magka-pressure and mauna yung reason na mag-rise above ang water on the top of aquifer. So we have also the water table or ginatawag na unconfined aquifer is an aquifer whose upper water surface or the water table is at atmospheric pressure and thus mauna reason na able siya to rise and fall na mag-rise and fall ang water. And then the last one, the perch. By definition, it is a local zone of unconfined groundwater occurring at some level above the regional water table, with unsaturated condition existing above and below it. So, they form where downward percolating groundwater is blocked by a zone of lesser permeability and accumulates above it. Kaning perching bed, mauni ang mahimong block sa percolation sa groundwater and maka-form siya og perch water table. And now let's discuss porosity. So porosity is defined as the ratio of the volume of voids to the total volume of soil or rock mass expressed as percentage. So we have a formula here. Porosity percentage is equal to volume of voids in a given mass over the volume of given soil mass. So we have two types of porosity. We have the primary and secondary. So most materials within a few hundred feet of the Earth's surface contain solids and voids. So kanang mga porosity or voids is mga spaces na sa tuang soil and rock which contain either water or air. And kanang mga downward percolating water na makollect sa mga voids and mao na siya ang mahimong water available for wells and mga springs. So the two types of porosity is the primary and the secondary. And the primary porosity refers to the openings that developed at the time the material was formed or deposited. And then the secondary porosity refers to the openings formed after initial formation or deposition of immaterial. So a good example aning primary porosity is the voids between particles in a sand and gravel deposits. So and for secondary porosity na mga process na maka-create ani nila like physical weathering or chemical or biological action and other stresses na maka-produce of fractures and joints. And kani sa secondary porosity is a common geologic material near Earth's surface, and kani sad siya na type sa porosity is enable or able the contaminants to move with little reduction or filtration. So together with porosity, we have the specific yield. So by definition, it is the ratio of the volume of water that an unconfined of fair soil or rock releases by the gravity drainage to the volume of the soil or rock mass. So we have the specific yield percentage formula here, the volume of water drained over the volume of given geologic material. So it means katong mga water na na-release from the aquifer by gravity drainage. So a material that has high porosity, such as a clay, does not necessarily yield a high volume of water if kana na material has low permeability. And kana na material is low in a specific yield. So we have here kaning table 7.7-1 shows comparison of porosity, comparison sa mga porosity and specific yield of some geologic materials. So we have here the engineering geology considerations in planning. So first is the corrosivity. So corrosivity na mga soil na corrosive sa mga materials na atong gigamit in constructing agricultural waste management systems, and we should consider that in designing. And then we have also the location of water table. The elevation and shape of water table may vary. So pag high ang water tables or ang perch water tables in borough areas, so we can create access or maka-accumulate problems for heavy machinery. So sa depth to rock, occurrence of hard, dense, massive, or crystalline rock at a shallow depth may also require blasting or heavy excavator to achieve the design grade. If also the rock surface is irregular, differential settlement can be hazard for steel tanks and monolithic structures, so such as reinforced concrete tanks. And then we have the stability for embankment and excavated cut slopes, the excavability, the seismic stability, the dispersion, permeability, puncturability, settlement potential, shrink, swell, topography, the availability and suitability of borrow materials, so presence of abandoned wells and other related of past use. So now let's talk about the factors affecting the groundwater quality considered in planning. So first, we have the attenuation potential of soil. So daghan of biological, physical, chemical processes breakdown na nag-lessen sa potency nga nag-reduce sa volume sa mga contaminants moving sa soils sa root zone, and mao na ginatawag na nagkataas ang attenuation sa soil if nagkataas ang clay content, soil depth, distance increases between the contaminant source and the well or spring. So organic materials in the soil also increase the attenuation potential. So number 2, the groundwater flow direction. So a desirable site for waste storage pond or treatment lagoon is in the area where groundwater is not flowing away the site toward a well or spring or important underground water supply. So kana sang a slope sa land nag-indicate sa na siya o groundwater flow direction. So number 3, we have the permeability to aquifer material. So the ability or property sa soil na makatransmit og water and air sa isa ka aquifer na material. And then number 4, the hydraulic conductivity. So the hydraulic conductivity of the soil is measure of the soil's ability to transmit water when submitted to a hydraulic gradient. And then we have hydraulic head. So hydraulic head is the energy of water, um, or mass produced mainly by differences in elevation, velocity, pressure, and expressed in units of length or pressure. And then number 6, the hydraulic gradient. It is the change in the hydraulic head per unit distance sa flows sa flow of in a given direction. So it is expressed in units of weight, no, kanang elevation, and then the distance. So groundwater velocity is a function of hydraulic gradients. So we have the hydrogeology or hydrogeologic setting. So studies sa mga occurrence, movement, and quality of underground water. And then the land topography, we have the proximity to designed use aquifer, recharge areas, and wellhead protection areas. Number 10, the type of aquifer, and then the last one is the vadose zone material. And that's end our discussion sa lecture 7 sa topic 4, which is about the geologic material and groundwater.